In this video, I'm going to show you how OSPF designated router election works and show you how to change the designated router for a LAN segment. So in this topology here, I've got 4 routers and they're all connected to an access switch. In addition, they all have Ethernet interfaces. So this is a broadcast network. All these routers are assigned to the same VLAN, and in this lab it's VLAN 10. So that would be interface FA01, 02, 03, and 04. In addition, they're enabled with OSPF, and they're all assigned to area 0. You'll note as well that OSPF is often connected with Ethernet interfaces, and they're often on a point-to-point network where you have 2 neighbors connected with the same subnet. There are some instances within a data center, for example, where you could have a group of switches connected through an access switch like this, and they're all assigned to area 0. And OSPF will detect that they're Ethernet interfaces and automatically assign them to a broadcast network type. Remember with the network type video that I changed the network type from broadcast to point-to-point since the OSPF routers were connected on a point-to-point link in the same subnet. In this example, they're all in the same subnet, all 4 routers. As a result, they have to be assigned to a single VLAN. So with this topology, OSPF will elect a designated router and also elect a backup designated router. So they're referred to as DR and BDR. So what happens when all these routers start up? OSPF will elect the designated router based on the router with the highest priority. So the default priority on a router is 1. So when all priorities are equal, then OSPF will elect the designated router based on the highest router ID. And here the router IDs are loopback interfaces. So based on the router ID, since the priority wasn't changed, it would be R4 that's selected as designated router, since it's got the highest numerical value, 192.168.2554. What I'm going to do in this lab is change the designated router from R4 to R2. And I'll do that by increasing the OSPF priority on R2 to 100. Then I'll restart them all and show you the results. So what I'll do is I'll go to R1 and show you the current neighbor adjacencies. So notice here the neighbor ID. That's currently the router ID. That's the loopback address, since priority is equal on all the routers currently. And 192.168.2554, that's the DR for R1, and all the other routers as well. The priority is, as mentioned, is 1. And the BDR is R3, since that's the second highest router ID, 192.168.2553. If it's not DR or BDR, it is two-way DR other. So that's all correct. Now we'll go to R2, and I'm going to change the OSPF priority on FA00 interface to 100. This will be advertised to the other routers. That's all there is to it. And I'm going to copy run to start here. Do a show run. IP OSPF priority 100. So I'm going to recycle these devices and show you the new neighbor adjacencies. So I'll go back to R1 now. Notice now R2 is the new DR, 192.168.2552. There it is there, 192.168.2552. It's got the priority 100. It is the DR, full adjacency. And R4 is the backup DR or BDR. That's since it's got the highest router ID. So if the rest of them have a priority of 1, then it becomes the router ID that decides the BDR, 192.168.2554. So the previous DR is now BDR. Go to switch 1 here. I just want to show you that they're all in VLAN 10, FA01, 2, 3, and 4. And that's the interfaces there. Back to R2, show another command. This is R2 where the priority was increased to 100, and there it is there, priority 100. And that concludes the video.